Hello everybody, welcome back to Teach Me to Science, and today we're going to be talking about Hess's Law. Let's start by defining what Hess's Law is. Hess's Law is a useful tool which allows us to take known enthalpies of reactions and solve for unknown. There are a couple of rules which you need to know before you even start doing problems. The first rule is that if you multiply a reaction by a number, you also have to multiply the enthalpy by that number. The second rule is that if you reverse the products and the reactants of a reaction, then you have to switch the sign of the enthalpy, which means either a negative becomes positive or positive becomes negative. And the final rule is that if something appears on both sides of the reaction, then it gets canceled out. Now let's do some examples. Alright, so in this first example we have a simple reaction, only one reaction, and its enthalpy. Our goal is to get it to 1/2 C goes to 1/2 A plus B. The first thing you may notice is that the C is on the opposite side of the reaction that it was when it started. This means that you have to flip the reaction to make the reactants the products and the products the reactants. After that, you have to figure out what you need to multiply the reaction by to get the coefficients to be what you want them. In this case, you multiply the whole reaction by 1/2. So first we flip our reaction, which gives us C goes to A plus 2B. Next we multiply the whole reaction by 1/2, which gives us 1/2 C goes to 1/2 A plus 2/2B. This simplifies to 1B. This gives us the final reaction that we were looking for. Now all that's left to do is switch the sign of our enthalpy and multiply our enthalpy by 1/2. So we divide 340 by 2 and flip the sign from negative to positive. This gives us a new reaction enthalpy of 170 kilojoules per mole. Now let's try another example that's a little bit more tricky. Now instead of one reaction, we have two reactions with known enthalpies and one unknown. There are a couple things to notice when you begin this reaction. First, D in the second equation has moved from one side to the other. This means that the second equation needs to be flipped. Next, you may notice that there are no C's in our final answer, which means we need to cancel out our C's. To cancel out our C's, what we need to do is flip our second equation and multiply the second equation by 3. And while this problem may look really complicated, that's all you need to do to solve this problem. If we switch our second equation and also multiply it by 3, and then add our two equations, we'll find that our end result is 8A goes to 2B plus 3D. Let's start from the beginning just to prove it to ourselves and practice our rules. So we start with 2A plus B goes to 3C, and we're going to leave that equation alone. Next, we're going to flip our second equation so the C is on the reactant side, and we're going to multiply it by 3, which gives us 3C plus 6A goes to 3B plus 3D. Now you can see here that one of our B's cancel, which leaves us with 2 B's on the product side. Our 3 C's cancel out on each side, and we add the A's to get 8A total. This leaves us with our desired reaction, which is 8A goes to 2B plus 3D. Now don't forget, we're not done here. We still have to multiply and switch the signs of our second enthalpy. So if we switch the sign of our second enthalpy, we get positive 110 kilojoules and multiply it by 3, then we'll get 354 kilojoules per mole. That's it for this video on Hess's Law. I hope you've enjoyed this video. If you could, please like and subscribe. I would really appreciate it. Thank you for watching. Bye!